Welcome to This Explainer. You know, for decades now, the absolute brightest minds in physics have been chasing a ghost. We've been searching for a single elegant set of rules that explains the entire universe. But lately, people are starting to ask a really tough question. What happens if our very best idea is actually failing and we just don't want to admit it? So, here is the massive elephant in the room. Why hasn't string theory actually been proven yet? I mean, it's supposed to be the ultimate theory of everything. But after years of massive particle collider experiments and thousands of brilliant careers dedicated to it, string theory hasn't given us a single unique prediction that has been confirmed in the real world. So what exactly is going wrong? To get to the bottom of this, here's our roadmap for this explainer. First, the core string theory problem. Then, we'll break down the THD framework, look at predictive compression failure, explore the validation tests, and finally, unpack the real-world implications. All right, let's jump right into part one, the string theory problem, a bridge too far. Think of string theory right now like a massive bridge meant to connect gravity with the quantum world. But the bridge just keeps getting longer without anyone building structural supports to actually hold it up. That's the core issue. Every time an experiment fails to find evidence, the math just adapts and expands to survive. The math keeps growing, but the hard, empirical evidence from the real universe isn't there to constrain it. And history tells us exactly what happens when this occurs. Think back to the old Ptolemaic system, when people honestly believed the Earth was the center of the universe. When their math didn't match what they saw in the sky, they didn't scrap the theory. They just added epicycles, basically circles within circles. Eventually, it got so complicated just to avoid being proven wrong that the whole thing collapsed under its own pressure. Ether theory did the exact same thing. Theories break when they get too complex without real evidence. Moving on to part two, the THD framework explained, a universal rhythm. To truly figure out what's going wrong with our modern physics, we have to look at the groundbreaking work of Kevin L. Brown, a researcher, inventor, and author. He developed a completely new way to measure the stability of systems, which gives us a completely fresh lens to look at this problem. This framework is called Triune Harmonic Dynamics, or THD for short. And THD isn't just a bunch of math on a chalkboard. It's a highly powerful diagnostic tool. It maps out how literally any system, whether it's an energy wave, a physical crystal, or even a theoretical model like string theory, emerges, gets tested by pressure, and eventually has to resolve into a stable state. Everything follows a universal rhythm. Notice the 3-6-9 harmonic rhythm Kevin L. Brown discovered here. Step 1 is form, the system emerges. Step 2 is transform, structural pressure builds up as it interacts with reality. And step 3 is integrate. It must lock into a stable pattern or break apart entirely. The crazy thing? Right now, string theory is totally stuck in step 2. It's gathering massive structural pressure but refuses to lock into a testable reality. Which brings us to part 3, predictive compression failure, diagnosing the disease. Applying THD directly, we can identify the exact illness string theory is suffering from. It's called predictive compression failure. See, a healthy scientific theory should shrink its possible answers as we do more experiments. It acts like a funnel, guiding us toward one specific truth. But string theory? It's acting like an expanding balloon. Instead of narrowing down, it just creates more and more possible universes every single time we test it. So where is all this pressure actually coming from? Well, we built massive, multi-billion-dollar machines like the Large Hadron Collider. We looked for superparticles. We found absolutely nothing. We looked for extra dimensions. Nothing. But instead of saying, hey, maybe the theory is flawed, string theory just invents new, completely untestable parameters. That sends the system's structural stress right through the roof. To put this in plain 8th grade English, if you literally can't be proven wrong because you constantly change your story, you are no longer describing physical reality. You're just doing really creative math. A real theory has to become more precise as evidence piles up, not infinitely more flexible. Let's put this to the test in part 4. Validation tests, testing the hypothesis. Because good science doesn't just make claims, right? It tests them. We validate this THD hypothesis by tracking measurable signals over time. If scientists keep finding zero evidence for extra dimensions, and string theory responds by expanding its possible models even further, the structural pressure index rises. It's a massive red flag telling us the theory is diverging from reality and approaching a breaking point. But listen, for Kevin L. Brown's hypothesis to be valid science, it has to have falsification parameters, meaning we have to know exactly what would prove his diagnosis wrong. If string theory makes a unique prediction tomorrow, and we actually find extra dimensions or supersymmetric particles, boom, string theory works. The pressure resolves, and the THD failure diagnosis is proven completely false. However, if no physical proof is found, we hit what's called the critical threshold. If the structural pressure gets too high with zero physical proof, string theory has to be formally reclassified. It loses the title of a physical theory of our universe. It gets demoted to just a useful mathematical framework. Finally, Part 5, Real-World Implications, the Future of Physics. You might be wondering, okay, why does this matter to me? Well, it demands a massive shift in how we think. The old standard for science was simply, can the theory explain reality? And that allowed for endless, flexible math. The new standard, driven by THD, absolutely must be, does reality increasingly constrain the theory? We have to stop rewarding theories just because their math is pretty and start demanding that they predict the real, measurable universe. This literally impacts engineering, policy, and yes, your tax dollars. By using the THAD framework to catch predictive failure early, we can stop wasting billions of dollars and decades of brilliant researchers' lives on theories that can never be proven wrong. We can redirect all that funding into fresh, experimentally tested models that actually move humanity forward. So I'll leave you with this thought. If we finally demand that our science compresses toward the measurable truth, and we start funding theories that can actually be proven, what incredible real-world breakthroughs are waiting just around the corner? Thank you so much for exploring the THD framework and the future of physics with me in this explainer. Keep asking those hard questions.